The question is how to calculate the total volt-ampere load on a panel for lighting, specifically regarding demand factors in the National Electrical Code, or NEC. The NEC sections 220.42 and 220.20 are relevant. NEC section 220.20 addresses overcurrent protection for continuous loads, mandating a 125% factor when sizing overcurrent protection for circuits serving continuous loads. NEC section 220.42 offers demand factors for branch circuits based on load type, and specifies a 100% demand factor for lighting in office buildings. The value that the lighting load volt amps needs to be multiplied by to calculate the total volt ampere load on a panel is 100%. NEC section 220.20 focuses on sizing overcurrent protection and does not apply to the overall panel load calculation. It mandates a 125% demand factor specifically when determining the appropriate size of overcurrent protection devices, such as breakers or fuses, for circuits supplying continuous loads. NEC section 220.42 dictates the demand factors for branch circuits based on the specific type of load. For office buildings, the NEC specifies a 100% demand factor for lighting. Therefore, the full volt-ampere load of all lighting fixtures should be entered into the panel schedule without applying any multiplication factor. To correctly calculate the total volt-ampere load on a panel, one must apply a 100% demand factor for lighting loads. To elaborate, the NEC outlines specific requirements for calculating electrical loads to ensure safety and prevent overloading electrical systems. Correctly determining demand factors is crucial for accurate panel schedules and proper circuit protection. The NEC section 220.20 is specifically about sizing overcurrent protection for continuous loads. A continuous load is defined as a load where the maximum current is expected to continue for 3 hours or more. For continuous loads, the overcurrent protection device must be rated at not less than 125% of the continuous load. This requirement is intended to prevent nuisance tripping of the breaker due to heating. For example, if a circuit has a continuous load of 20 amps, the overcurrent protection device must be rated at least 25 amps, since 20 amps times 1.25 equals 25 amps. Standard breaker sizes are typically 15, 20, 25, 30, 35, 40, 45, 50, and so on. Therefore, a 25 amp breaker would be required in this case. The NEC section 220.42 provides demand factors for various types of loads. Demand factors are multipliers used to estimate the actual load that a circuit or panel will experience under normal conditions. These factors take into account that not all loads will operate at their maximum rating simultaneously. For lighting loads in office buildings, the NEC specifies a demand factor of 100%. This means that the total volt-ampere rating of all lighting fixtures connected to a circuit should be used when calculating the total load in the panel. Unlike continuous loads for overcurrent protection, there is no additional 125% multiplier applied to the lighting load itself when determining the panel load. The NEC provides different demand factors for different types of occupancies and loads. For example, the demand factor for general use receptacles in an office building is typically less than 100%, reflecting that not all receptacles will be in use at the same time. However, for lighting in office buildings, the NEC assumes that the lighting will be used extensively, hence the 100% demand factor. When filling out a panel schedule, the volt-ampere load for each lighting fixture should be entered directly without applying any additional multiplier. The panel schedule will then sum up all the loads to determine the total load in the panel. This total load is used to select the appropriate size of the panel board and the main overcurrent protection device. It is important to distinguish between sizing overcurrent protection for continuous loads, where the 125% factor applies, and calculating the total panel load for lighting, where the 100% demand factor applies. Applying the 125% factor to the lighting load when calculating the panel load would result in an overestimation of the actual load, potentially leading to an oversized panel and unnecessary costs. In summary, The NEC requires a 125% factor for sizing overcurrent protection devices for continuous loads, but it specifies a 100% demand factor for lighting loads in office buildings when calculating the total panel load. Adhering to these requirements ensures accurate panel schedules and appropriate circuit protection. To further illustrate, let's consider a practical example. Suppose an office space has 100 lighting fixtures, each with a volt-ampere rating of 50 volt-amps. The total lighting load would be 100 fixtures times 50 volt-amps, which equals 5000 volt-amps. When filling out the panel schedule, the total lighting load entered would be 5000 volt-amps. Since the demand factor for lighting in office buildings is 100%, the total volt-ampere load in the panel due to lighting is simply 5000 volt-amps. However, when sizing the overcurrent protection for the lighting circuit, if the lighting is considered a continuous load, the overcurrent protection device must be rated at least 125% of the continuous load. In this case, 125% of 5000 volt-amps is 6250 volt-amps. Assuming a voltage of 120 volts, the current would be 6250 volt-amps divided by 120 volts, which equals approximately 52.1 amps. Therefore, the overcurrent protection device should be rated at least 60 amps, as that is the next standard size above 52.1 amps. It is important to note that the 60 amp breaker is only required for the circuit supplying the lighting, while the panel load calculation remains at 5000 volt-amps. The distinction between these two calculations is crucial for accurate electrical design. Moreover, the NEC provides guidelines for calculating voltage drop in electrical circuits. Excessive voltage drop can cause lights to dim and equipment to malfunction. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. When calculating voltage drop, the actual load on the circuit must be considered. In the case of the lighting circuit, the voltage drop calculation would be based on the 5000 volt-amp load, not the 6250 volt-amp value used for sizing the overcurrent protection. In addition to lighting loads, the NEC also provides demand factors for other types of loads, such as receptacles, 8-track equipment, and motors. These demand factors are based on statistical data and engineering judgment, and they are intended to reflect the actual load that the electrical system will experience under normal operating conditions. Using the correct demand factors is essential for designing an efficient and reliable electrical system. It is also important to consider future expansion when designing an electrical system. The panel should be sized to accommodate future loads, and spare capacity should be provided for additional circuits. This will prevent the need for costly upgrades in the future. Furthermore, local building codes and regulations may impose additional requirements beyond those specified in the NEC. It is important to consult with local authorities to ensure compliance with all applicable codes and regulations. The NEC is updated every 3 years, and it is important to stay current with the latest edition. Changes to the NEC can impact electrical design and installation practices. Electrical engineers and contractors should participate in continuing education courses to stay informed about the latest changes to the NEC. The NEC also provides guidelines for the installation of electrical equipment, including wiring methods, grounding, and bonding. Proper installation is essential for ensuring the safety and reliability of the electrical system. Electrical work should only be performed by qualified and licensed electricians. In conclusion, the NEC provides comprehensive guidelines for calculating electrical loads and designing electrical systems. Understanding and applying these guidelines is essential for ensuring the safety, reliability, and efficiency of electrical installations. The distinction between sizing overcurrent protection for continuous loads and calculating total panel loads is particularly important for accurate electrical design. Correctly applying demand factors and considering future expansion are also critical for creating a robust and sustainable electrical system.